All right, we're going to look at one last type of confidence interval, and this is for paired data. So paired data, if you remember from chapter 9, this would be that matched pairs idea, typically a before and after, or if you compare up two people or two things together, you could compare the two of those. So I have all three of the processes we've learned. So we have the one mean z interval. Okay, and that was if you have your population standard deviation. We did the one mean t interval, and that's if you have your sample standard deviation. And now we're going to look at a paired t interval. And so this is the difference of two population means. So maybe you have a column that is a before and an after. And what you're going to do is you're going to subtract these two columns. So you'll have a third column you'll call the difference. And so you'll subtract them like A minus B. And what you're going to focus on is using this differences column. Okay, so when we look at the standard deviation, what we're interested in is the standard deviation for the difference column. So not the before and not the after, but just the difference column. So that would also be a sample standard deviation. We would want to look at the differences column and see if it's normally distributed. So if we needed to make a normal probability plot, we would use this differences column. Okay, for that. Or your sample size. And so your sample size is just however many entries there are in this differences column. And then we're looking for a random sample, and that's paired data. The name of this test is a paired t interval. And then to get our confidence interval, this d star here, or d bar, sorry, is the average of the differences column. So if you're working off the differences column, it's just that average of that column. T star is the same as it was before when we did the one mean t interval. Okay, so you can use that t.inverse command if you were wanting to look that up. SD, so that was your standard deviation of your differences, and then divided by the square root of n. So really very similar formulas to the other ones. I'd say the biggest difference is this d bar, which is the average of the differences column. And then your conclusion is we are blank % confident that the difference between the mean of whatever's in column A and the mean of column B is somewhere between the two numbers we got from step I. All right, so let's take a look at how to do one of those.